Hi everyone, welcome back. Today we are going to do some exercise for the subtopic 8.1. So the first question is, if a disc 30 cm in diameter rolls 65 meter along a straight line without slipping, calculate the number of revolution. So the first question, you need to calculate the theta. The number of revolution is equal to the S over R. So from the question, we have the value of the diameter, so convert to the meter first in SI unit. So diameter 30 centimeter, so we find the radius is equal to the 0.15 meter, and the S or the distance is equal to the 65 meter. So S is going to be 65 meter already in SI unit. So next you need to substitute the value into the formula. So we have S is equal to 65 and R is equal to 0.15 meter. Don't forget to convert into SI unit first before you substitute the value into the formula. And then therefore we get the value of the theta is 433.33 radian. So don't forget to convert into number of revolution, because the question states that the number of revolution. So one revolution is equal to the 2 pi radian. So if the number of revolution, so x revolution is equal to 433.33 radian. So divide by 2 pi. So you will get the number of revolution in revolution, which is 69 revolution. Question B. The angular displacement would be true by a speck of gum on its ring. Actually, this question you need to calculate the theta. So the theta we already calculate in the first question. Then we get 433.33 radian, and you need to convert into pi radian. Instead, you need to divide by pi, and then the answer will be 138 pi radian. Next question we have, during a certain period of time, the angular displacement of a swinging toy is described by theta is equal to 5 plus 10t plus 2t squared. And you need to calculate the angular displacement, angular speed, and angular acceleration at time t is equal to 3 seconds. So the first question, you need to calculate the angular displacement. So angular displacement, theta is equal to, already given from the questions, is 5 plus 10 t plus 2 t squared. So just substitute the value of t is 3 seconds. So we get 5 plus 10 times 3. So we have 30 plus 2 times t, 3 square, we have 18. So we got 53 radian. Angular speed, we use omega is equal to d theta over dt. So you need to differentiate the angular displacement, and we get differentiate the 5, you got 0, 10t, and we have 10 plus differentiate 2t squared, so we get 4t, and then substitute the value of t, and we have 10 plus 4 times t is 3, and therefore we got the answer is 22 radian per second. And to calculate the angular acceleration is alpha equal to d omega over dt. So we already got the omega, which is 10 plus 40. So we differentiate over t, and we got differentiate 0, 10 we got 0, and 40 we got 4. So the answer is 4 radian per second squared. Next question, we have the wheels of a bicycle length 30 revolutions. As a bicycle reduces its speed uniformly from 50 km per hour to 35 km per hour. The wheels have a diameter of 70 cm. So first of all, you need to identify, or you need to write down all the information given. So from here, we get the theta. So theta is equal to 30 revolution. So make sure you convert into SI unit first. So theta is equal to 30, so convert into radian, times 2 pi, and we have 60 pi radian. Next, convert the speed 50 km per hour to meter per second. So we have u equal to 50 km per hour, so convert into meter per second, and 50 times, so kilometer 10 to the power of 3, convert into meter, and divide by per hour, we convert to per second, so 60 times 60, and we got 30.9 meter per second for the speed or initial speed. And then v equal to 35 kilometer per hour. This one also you need to convert into meter per second first. Okay, so 35 10 to the power of 3, convert to meter, and divide by 60 times 60, convert to second, and we have the answer is 9.7 meter per second. And we calculate the angular acceleration alpha. So for question A, alpha, so we're going to use the equation of omega square equal to omega naught square plus 2 alpha theta. This equation is familiar to the linear motion, which is v square equal to u square plus 2as. So you need to calculate the omega first, because from the question we got the initial velocity and final velocity in the linear motion. So you need to calculate the omega, okay, by using omega equal to v over r. So omega square v over r, we got here is 9.72 divided by r. We have 0.35 here from the question. Given is 70 centimeter in diameter, so you need to get the radius, okay, convert into meter. So radius gonna be 0.35 meter. So substitute here 0.35, don't forget to square, and for the omega naught or initial angular velocity, 13.9 divided by 0.35 square plus 2 alpha and the theta. We already convert into radian times 60 pi, and then rearrange, we get the alpha equal to minus 2.13 radian per second square. Okay, please take note, make sure you write down the correct SI unit. Next, question B, if the bicycle continues to decelerate at this rate, determine the time taken for the bicycle to stop. Okay, for the first question, T0, so U equal to 13.9 meter per second, and T1, the final velocity we have 9.72 meter per second. So for these questions, need the continue to decelerate, means that you need to calculate the extra time. The extra time needed from v or final velocity 9.72 to final velocity equal to 0, because taken for the bicycle to stop. So become to stop means that the final velocity is equal to 0. Alright, so we are going to use the equation of v equal to u plus at. So the final velocity is equal to 0, and the initial velocity is 9.72. The final velocity will be the initial velocity for these questions. So we put 9.72 for the initial velocity plus a. We use the same angular acceleration, or acceleration is equal to minus 0.748 and times t, so we can calculate the value for t is 13.1 second. The acceleration we can calculate from the linear motion, v square equal to u square plus 2as, and we already convert the final velocity and initial velocity to the SI unit. So we have v 9.72 square equal to u is 13.9 square plus 2a as equal to 0.35 times to 60 pi, because theta is equal to S over R, and you can calculate that S equal to R theta, and then we can get the value for the acceleration is equal to minus 0.74 meter per second square. Alright, next questions. A blade of ceiling fan has a radius of 0.4 meter, is rotating about a fixed axis with an initial angular velocity of 0.150 revolution per second. The angular acceleration of the blade is 0.750 revolution per second square. You need to determine the angular velocity after 4 seconds. So first of all, you need to list down all the information given. From the question, we have the radius is equal to 0.4 meter, and then the initial angular velocity omega naught is equal to 0.50 revolution per second. You need to convert to the radian per second, so equal to 0.150 times 2 pi radian equal to 0.3 pi radian per second. Next, you need to convert the angular acceleration alpha equal to 0.750, convert into radian times 2 pi, and then we get 1.50 pi radian per second square. To calculate the angular velocity, so we use the equation of omega equal to omega naught plus alpha t, and omega naught is equal to 0.3 pi plus alpha is equal to 1.50 pi, and times t is 4 seconds. So omega or final or angular velocity is equal to 19.8 radian per second. B. The number of revolution for the blade turns in this time interval. So we apply the equation of theta equal to omega naught t plus half alpha t square, and then we substitute the value of omega 0.3 pi, t is 4 seconds, and plus half alpha is 1.5 pi, and times t 4 square, and then we get theta equal to 41.5 radian. So don't forget to convert into a number of revolutions. So theta equal to 41.5 radian, convert to the revolution. So 1 revolution equal to 2 pi radian, and then we have 6.61 revolution. Question C. The tangential speed of a point on the tip of the blade at time t equal to 4 seconds. So we use the equation of V equal to R omega, and then substitute the value of R 0.4 times omega is 19.8, and then we get V equal to 7.92 meter per second. Okay, that's all. Thank you very much.